over a few other things. So before I go over awk, I have to go over a few other things because awk is tied into it. Awk is the most powerful shell command. It's also the most complicated. So we need to look at some stuff. One of the commands we need is tr. Oh no, it's just the projector. Yeah, it'll be on the video. It'll be fine. It's just a prompt on the side, anyways. But okay, so what the tr command does, you can't run it by itself. You can't just like say I'm going to pass a file to tr or something like that. You can only use it as a string, which means you have to pipe something to it. It's the only way you can use tr. And what tr does is, well, basically you can take one thing that's a delimiter and turn it into something else for a delimiter. And this is really great for if you need to do tabs. And the way awk works is you have to have everything tabbed. And if something's not tabbed, awk can't work on it. So everything has to be done in these perfect columns for awk, and it has to be all tabbed over. If otherwise, it won't allow it, type thing. So we basically need to convert all files to be tabbed. So if we just look at the password file, for instance, if I look at that one, just cat, right? etc/passwd. Now note you have to be root in order to do this. So I did the su space -- first. But okay, so I'm looking at this file, right? And so we can see what our delimiter is here. It's a colon, right? So that's what's separating our fields or different parts of the text here for this file for each line here. So for instance, root here is the name of the user. X here is going to be the password. And then another colon here. And then 0 here is the user ID. The next 0 is the group ID. And then the next one right here is the actual group for it. And then the next one after that /root here is going to be the home directory. And the next one after that is the shell that they use, which shell it is, which is /bin/bash. Alright, so that's how that whole file breaks down. So, but what if I want to process that with awk? Well, in order to do that, I need to first cat it like this, right? And then I can pipe it to tr, because again, I can't just tell it, hey, if I want to process this file, I can't say, tr and then this file. It won't allow it. It has to be piped. All input has to be piped to tr. So I have to do tr. And by the way, this is on the Linux Plus and the LPI exam. This command is, along with a bunch of the commands I'm going to be going over, is on the actual Linux Plus. So you need to know this stuff. Also, some of it's on your final exam too. So another reason you need to know it. But alright, so in this case, what we have here, we have a colon, right? That's our delimiter here. And then I need to change this into something else. So if I want to change this, I can make it a tab. But what's the special hotkey for, what's the special escape character sequence for a tab? Anybody remember? No, it's not the caret top. It's not caret top. That's for beginning of a line with a regular expression. That's what you're thinking of for that. Yeah, it is a slash, and then what? Correct. You slashed them what? Anybody? Not forward slash. Just no, $is the end of a line. No. T for tab, like that. /m would be new line, etc. And this also gets replicated also in printf, which we'll get into, which is a more powerful version of echo, more or less. It's like echo on steroids. And so it allows you to do more advanced like programming type structures. And that's really important because it's used with awk like crazy. Printf is typically what's used with awk for displaying things, because you can display fields and all this stuff. So it's better than echo would be for that. So it allows you to have more control and power. We'll go over that in just a second. So bam, check it out. Now suddenly this entire file is properly spaced out with tabs, and it's ready to be processed by awk.
So it took every colon and replaced it with a tab.
Yes, it took every colon and replaced it with a tab. That's correct. So it's what the tr command is good for. This can be used for a lot of stuff. You can take one file input and redirect it and make it basically a totally different setup for its delimiter to another file. And you might go, well, how am I ever going to use that? Well, for instance, CSV is a common format that's used with spreadsheets and database systems. If it's outputted into CSV, it could be separated by either commas or tabs typically. And you could basically easily translate that into one of these other setups. For instance, you could take those colons and make it become commas or something like that. If there's something that needs to be separated by a certain thing for a particular program for whatever format, you can change it easily with TR for whatever the separators are going to be. Does that make sense?
So now you could use awk on that file because now everything's
Right. Now you can use awk on this file. You sure can. And I can output this as a different file, or I could just pipe it to awk and just make this command even longer. So I take the output coming from this whole tr thing and then pipe it yet again to awk. So from here you would then pipe it to awk from there, and then so on and so forth. And this line's going to get long, but you get the idea. So you can do that. Is this making sense? So that's basically how you use tr right there. There's some other ones too. There's expand and unexpand. What expand will do is it will take tabs and convert it to spaces. And what unexpand will do is it'll take spaces and convert it to tabs. So say you have something spaced over like 8 times and you're using 8 space tab, which is standard tab, right? And you might be going, well, why do I care? Okay, for instance, Python. Here's a really good example, right? Say when the file got saved out for whatever reason, it didn't really get associated with tabs for it, and we already know what happens. Tabs are actually part of the programming language for Python, right? And if something's not tabbed over, it out flat just ends that decision structure or loop or whatever because it didn't get tabbed. So what you can do with like unexpand is you can take those spaces where someone hit the space bar like 8 times or something like that and just convert them to tabs with unexpand on that Python file, and now suddenly it works everywhere there wasn't tabs done where someone accidentally hit the space bar 8 times instead of hitting the tab key. So there's a good example of why you would use something like unexpand. Another tool here, let me show you yet another one here. WC. Alright, and so WC gives you all kinds of information like number of lines in a file and like how many characters long a file is and how many characters total there are in a file, etc. And so it gives you basically statistics on a file, if you will. What's that? WC? I don't know off the top of my head, but it basically gives you statistics on a file. Things of that nature. You're wishing. All right, so depends. You may not want what you were asking for. Sometimes find that out in art class. So from here, there's head. We've gone over this. This is real nice and useful. For instance, I could pipe this into head. You might be going, well, why do I care? Head's going to give me like the first 10 lines or something of that nature. And if I look at head real quick with a -- help on it, this one right here is going to tell me with -n option on it that I can do a -n and then say how many lines I want. So maybe I only want the first 5 lines, for instance. It gives me the first 5 lines of that. Does that make sense? So now you can limit it down to what you do want or don't want. So maybe I want more than 10, maybe I want 15. So there's the first 15 lines. Make sense? Very useful. Tail works the same way as head, only you're just saying tail instead. So tail is going to be the end, the last like 15 lines in that case. Or I could change that to the last 5 lines, so on and so forth. So pretty cool. But there's a particular option in tail that's really useful, and that's the tail -f thing. So if I do tail -f like this on a particular file, like for instance var / log. Hold on a second. Let me ls this first. ls/var/log. Is it log or logs? It's log. Okay. So say I want to see what's inside of a particular log. Is it last log that I can do? Okay, yeah, I can't do that one. That's what I thought. Yeah, that one requires a special tool to run that one. Maybe I want the mail log, for instance. I don't know. So let me cat that. And this is where you get a lot of your info if you're having problems with the server. This is where you want to go. You'll get a lot of your information here from it. Let's try messages. That one's an important one. Actually, it's probably the most important one. Oh, I'm being an idiot. I was like, why isn't this working? Probably because I got the wrong directory. All right, so there's messages, right? This is like one of the main logs on the system is the messages one. And it has lots of messages. Well, that's a lot of stuff to go through. And if I got a problem happening right now, I probably don't care about, I don't know, the several thousand lines that come before the end. I really am not going to care because I'm only interested in what's going wrong right now and not what went wrong like days or weeks or months or years ago, literally. You have log rotate. I'm not getting into that right now. You could rotate your logs. But so say I want to take this file here. I only want to see the end of the file. So I'm just going to say tail. Well, I'm going to try to say tail. And so there, I only get the end of the file, which is great, the last 10 lines or whatever. But it gets better. And this is probably hard to see, so let me clear it just to help make it a little more clear. So there we go. And if I do tail-F, what happens here with this is that it's now interactive. And see, the prompt doesn't come back afterwards. It's because it's interactive now. So anything that's like happening with the server where it's getting logged or messaged will automatically appear here interactively at the bottom. So tail-F is extremely useful because it really helps you interactively hunt down the problems and issues with your server, and you can basically get interactive feedback with your server as things happen. Does that make sense to everybody? So, yeah, so you can see it in real time as it's happening with your messages. If you use a special option -F, tail-F, it's extremely useful for that. Right, as soon as that error occurs, you're going to see it literally, and you just interactively watch what's going on with your servers as it's happening. So this is really great when you're like testing out something. You can type up something in another terminal and go, okay, let's see what's going on, and bam, you can see it pop up right down below on the terminal right below it. On the second terminal there, we have tail-F. Does that make sense? Now I was doing this last night in Ubuntu. Let's see if it works in Fedora 17. But I found a cool trick, and now I know how to do this. If I click on Activities, and let's see if this does it on Fedora. I right-click it. Yes, it does. Awesome. And then I go over here. If I right-click it, I can say New Window, and this is how I can get multiple terminals going in the new system, which is like, thank God, because that was really frustrating. That's how you do it, because you can't just click on the terminal to launch a new one. It'll just take you to the terminal you have already. So instead, you have to right-click on it and say New Terminal, and that's how you can get to more than one. But so in here, I could basically be doing my server commands, or over here on this one terminal here, and then I could see it interactively update on the terminal below it here with my tail-F. Is this making sense? Yeah. So very cool. Right. Right. So what I'm doing on the one terminal with the other server, I'm seeing it update and what's going wrong happening right there on the fly as I do each command, as I test out each idea. That way I'm getting feedback on what I'm doing, what's going on with the server interactively. I did Control C just then. Now, and something else I want to point out on this. Now, you could be doing this from the client side for your commands that you're typing in on your client, and then you could be SSH'd into the server remotely, right? And it could be off somewhere, and you could run a tail-F on your SSH session that's on the remote server. See what's happening with your server from your client terminal that you're doing on your computer there. Does that make sense what I'm saying?
If you do something on the client computer, real time, you're going to see what that happens, what that does to the server.
Right, so you're locally doing something on the client on your system, but on the other terminal, you are actually logged in remotely with SSH. Everything's encrypted onto the server, and you're running a tail-F to see what's happening with the log files or what's going on with the server there. And then you can pop out of that and then go edit the server, fix whatever's going wrong. Maybe launch multiple SSH sessions. We have another one where you're going and actually manipulating the server into fixing it while you still have your tail-F. Leave it up and going if you want. It's whatever you want to do. Does that make sense, everybody? What? It can depend on what you're talking about. Some of it gets logged into your .ssh folder. I mean, sorry, yeah, .ssh folder inside of your user directory for when you connect. Huh? Yes, yes. I mean, like for instance, when you last logged in, it's the last log file. So it totally depends on what it is you're wanting to see. There's lots of logs. I mean, lots and lots of them. You have all kinds of servers that are in here. Your Apache can get directed here. It totally depends on what you want directed into where and what. Here's, for instance, HTTPD, and that's your Apache right there. So, if I pull this up right here and then I say slash HTTPD like that, bam, there you go. And then there's all the different logs for Apache, and I can actually go in and look at these different logs and what's going wrong with which server. Then remember, actually, when we set up our virtual host, we actually set it up to which one, a separate log file for each server, right? For each virtual hosted server. So we can actually check the log files for each particular virtual server. Okay.
Is established into what host. Do you know where I would view that?
For SSH?
Yeah.
You do that in the .ssh.
Because I want to do load, but I'm going to set up a secure connection between my terminal and workstation to the Oracle server.
Okay, let me show you something. ls-a here space slash home slash student. Alright, so we've already gone through SSH before. So check it out. You'll see in here, or at least I think I have. Have I not SSH'd into something before? Maybe I haven't on this one. Well, let's do it then. Let me just become a student real quick. SSH as root at localhost, for instance. Alright, do I want to create this new file connection and all that stuff? I say yes. Once I do that, and I log in properly, so now I'm SSH'd in, right? So I'm in there, I'm doing stuff, blah, 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 whatever. And so now I want to get out. So I exit, the connection's closed. Well, afterwards, if I want, I can do an ls-a, and check it out. We now have this whole beautiful, where's my cursor? There it is. We now have that folder. It's a hidden folder so that regular users don't screw it up. Inside this folder, if we go inside of that, this is actually on your final exam. So hope you remember it. Yeah. So hosts right here. Oh, sorry, that's not a directory, that's a file. I'm being an idiot. If I cat this known underscore hosts, it actually lists the known hosts, including the encryption key for the dash RSA, and then that's basically the passcode key getting sent through for encryption and everything. Yeah. And it said, who did we connect to? We connected to a local host, all this stuff. Here's our SSH. There's the dash RSA. Of course, I'd need to look at other files like when it was logged in, blah, 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 because remote logins will actually get logged in a different file than this. And that's server side, of course. And that's over in your logs. So that's a totally different ball game. Is this making sense, though? Okay. So, there's lots of log files. I'm not going to get into all that. There's tons of them. There's not very good documentation on it either, unfortunately. I haven't found a good book on logs yet. It's this really important thing that hardly anybody really goes into depth on. I don't know why. I really don't, but they don't. So it's frustrating. Let's see here. We got the who. We know who the who is command. All that fun stuff as far as that goes. Oh, yeah. Do you guys know sort and cut and unique? Probably. Did I go over that stuff? Okay, let's go over that real quick. Let's go over cut real fast. So let me just cd into etc, like so. Cool. Let me just cut. All right. First of all, let me cat the passwd file. So here we are back at the passwd file. Right. We're familiar with this now, right? Great. So let's cut it now. So if I do a cut here, I do a -d. This is my delimiter. What's my delimiter, guys? Anybody remember? Colon. Yep. I'm going to say colon. I need to tell it. And then I'm going to tell it how many fields I want. So this is also useful with awk, right? I can limit it down to just how many fields I want. And then I can convert this with a tr command over to have it be in tabs so it can be processed by awk. So you get a whole long process, right? So here's, for instance, say I only want the first field. I don't want that X because I don't care about it. So maybe I want the username and I want their home directory. So their home directory would be how many fields over. So mark would be like the first field here, right? X is the password, so that's field 2. So we definitely want 1 because that's their username, right? And then 3 here is their user ID. 4 is their group ID. 5 is their actual group. And then 6 is the one that's actually their home directory. So say I wanted only their username and home directory out of that. So if I do that there, and then I say like pass WD for that file there, wow, that was really blank. TC. Oh, I'm sorry, not F16. That's F with a comma in between. Sorry, 1 and 6. I was like, what is going on? No F16s, no fighter jets. All right, so this right here gives me just those 2 fields, right? So now I can take the same command, right? And don't forget, we can now pipe this into our tr, right? Say colon there, and then we could always, of course, go in here with our t, like so, and then now we got those 2 fields with it tabbed properly. So now it can be, this whole string here now can be taken yet further again with awk, at that point, or something of that nature, and this line can continue on. And their home directory from doing that. Yeah, it's pretty powerful, these shell commands. You can actually use them to process stuff and have it auto-generate things you need, which is useful if you're doing like LDAP or some of this other stuff. So maybe you want to create database entries based off the users on the system automatically with MySQL, for instance.
What was that tag D option?
The what?
Tag D option. Cut space tag D.
Oh, the dash D is your delimiter. Your delimiter in this case was the colon. I'll show you what I mean for colon. See? This is what separates the different fields here. The colon does.
Oh, okay.
Fields being each little piece of information.
So you're telling it, hey, I'm going to use the colon as my delimiter.
Correct. And that's another thing that's on the final exam too. That's another question that's on there. So knowing what a delimiter is matters. So yeah, you need to be aware of that one also. So yeah, so does that make sense for the cut? And that's what cut does. I can cut whatever I want out of there. It's basically lets you limit down just to the information you're interested in and not the whole enchilada, right? So that's really, really useful. Besides cut, there's also sort. So maybe I want to do something in alphabetical order or whatever. So I can sort it. This stuff could be all mismatched in here. You notice this stuff doesn't go in alphabetical order, right? So I can sort it like so. And if I sort /etc/pass WD like this, it will now put it in alphabetical order, or should anyways. Some semblance of that. Yeah, it does. It does. It's just wrapping around, but it is in alphabetical order now. See, before the file wasn't in alphabetical order. Now it is, and that's what sort does for you. Yeah, it's just sort space the file you want to sort, or you could just pass the input. So here's another fun thing, right? We got this whole thing going on right here with our TR and all that good stuff, right? Well, maybe not with the LS there, right? But see, I pipe that in. I can now pipe that into sort, and now it's going to sort it. So now it's what, tabbed and sorted and just cut down to just what we want and all that stuff.
Sort automatically does
Alphabetical order, yeah. And of course, we could also reverse our sort and make it in reverse order. So now it goes from last to first in alphabetical order. -R makes you go flip it in reverse. So now it does alphabetical order in reverse. Yeah, that's in quotes. That's /T there because that's escaping the T for the tab, and that does a tab character.
So it's telling TR to replace the delimiter colon.
Right. Yeah, because awk has to be tabbed for everything. It won't work unless it's tabbed. So all your files for input have to be tabbed for all of its separated for its fields. It considers each data object as a field as part of awk, but it must be as your delimiter for awk. It has to be done with tabs and cannot be colons or commas or anything like that. So you must convert whatever your delimiter is into tabs. You use that tr command to do that. So, and just going over some of the basic commands you can use that you need to know about to process the stuff to then bring it into awk afterwards. So, awk's the most powerful command, but you're going to have to do some cleanup before you get it into awk, typically. Because it's not going to, most files aren't ready to go into awk. So, or streamed input or something like that. You're going to have to do something with it to make it do what you want. You can even change an individual space to a tab if you want to, and consider that your space is your delimiter with tr. So instead of doing like the colon, for instance, on the say it was like a different type of file here, maybe I want the sort like that. So maybe instead of a colon, it was a space. See, that would be a space. Right. Exactly. You put the space in quotes so that way it can determine that it's a string space character. Making sense? Of course, for us, for this particular file, the delimiter is a colon, so I'm sticking with it. I just like the passwd file because it's such a great example of, yeah, it's very delimiter based, separated fields there, so it just makes for a great example of a file that is broken up with a delimiter, and it is an important file that's used on a regular basis too. That's the other thing about it. So that's the other aspect to this. Okay. Besides that, that's not all. There's also the unique, or UNIQ. Now, what does this one do? Now, this one's really useful with log files. And that's where it really shines. So now log files are notorious for having the same junk over and over and over and over and over again, like maybe 1,000 times in a row. And you really don't want to read all that stuff repeated over and over again before you get to the next entry that's actually of interest. Because who wants to really scroll through 1,000 entries of the same thing? It's exactly the same freaking thing. Well, how do we get rid? Right, because the error's just happening over and over and over again, so it just keeps logging it. As it keeps repeatedly doing it in a loop. So that sucks. So how do we get around not having to look at all that stuff? Well, the unique command comes to the rescue in this. So for instance, I can say uniq space, or at least I could try to. uniq. It helps if you have your cursor in the window. If you're going, hey, it's not working, blah blah blah. Check to make sure your cursor's actually in the window here on this virtual machine. Otherwise, it's not. That's not processing it. It's that your cursor is actually not in the window, and so therefore it's not working. But yeah, unique here, and then from there, I should be able to say /var/log/ I don't know, messages. Messages could end up getting logged a bunch of freaking times. All right, permission denied. I agree. I'm not root. It's right. I'm wrong. All right. Unique. Yeah, it's recorded. Don't worry. You got me saying that. You guys gonna like play that back to yourself for sleep or whatever. I can go to sleep now. He said he's wrong. It's all good. Exactly. There you go. Use it as your ringtone. Oh, dude, that's awesome. All right, so maybe I have last log in here, although it's not going to be as likely. Oh yeah, this is a binary file one, if I remember right. Do I have to type in last and then do last log? I forget. Yeah. There's not much to that one. That one's a binary file. Certain files require special magical commands in order to read them because they're binary log files and they're not in text format. And that's to prevent people from reading them. So that's what's going on with that one. It takes a special command to read it, actually. Let's see here. Well, I doubt cron jobs are going to be repeated. This cron job here is where you like set it up to where you can schedule for something to happen at a particular point in time. For like maybe you want to back up at this time at night or something like that, and you don't want to hang around to do that. Use a cron job. It'll set it up. You set up a cron job, and it'll go out. It'll go do whatever it is you tell it to do. Maybe run one of those scripts I showed you how to write. Maybe you have it do that, and you're at home asleep instead of having to stay at the workplace to do it, and the computer just runs and does it. So cron jobs are awesome. It will save you time, headaches, and frustration. Yeah, it's literally right here. If I could bring my cursor up to click on drag this one right here, cron. Yeah, CRN. It's in your book too. They're not hard. This is a very simple task to set up. So it's nothing complicated. All that stuff you go over is complicated. That's not complicated. Also, mail is in here, so your mail counts and stuff like that. All your different servers are going to be in here too. Here's your Samba one over here. Anything's going wrong with Samba, just go into your Samba folder and check out what's going on with it, so on and so forth. Actually, yeah, let's check out Samba right now. And Samba's got a lot of logs, and this is really great. Go check it out if you're having problems. Check it out on here to find where your problems are on like the bacon server, for instance, or whatever. It'll make everyone hungry. But log bacon server, and since we haven't looked at this will be interesting. It's an empty file. Awesome. Let's try localhost. See if localhost has anything. Well, I guess that means we had nothing go wrong, so that's good, right? Well then, that was a boring log. Let's try mail. I haven't really set up mail, but statistics. It's cat statistics. I'm not typing all that. Thank you. Nothing in there. Yay. Probably because we haven't set up the mail one. I'll check Spooler, but probably not going to expect much on that one. That's not, whatever. Yeah, the ones in blue are folders, so I should have known better. Nothing in there. Well, that's usually you have logs are for errors, so I've been getting on many errors. That's good. That's good. It's just frustrating to try to show it though. I don't know. Anyways, but say you had something repeat a lot, use a unique command, and that eliminates your repeated statements. I tell you what, let's do it this way. Let's make a brand new file. Let's do it over in slash. Okay, let me change users right now. It's the student. Like that. Let me cd to change the directory. Okay, so now I'm in home directory, right? ls. There we are. But cd into scripts, right? Alright, so in here I can sit there and do my ls and redirect that into something like listing.txt, and then I can run it again.
So you're appending it every time, so it's in there a bunch of times.
Correct. So if I cat this, now this is something I need to show you about this command. So of course we get the same stuff over and over and over again in here, which is really annoying. You're probably going, okay, cool, and so I could just use the unique to eliminate that. Well, not really. Let me show you. And this really brings up a good point about how unique works. You're like, oh my gosh, that's the same thing. It is. It didn't get rid of anything. No, it didn't. Why not? Well, because here's the thing about unique. Things have to be touching. They have to be like repeated right next to each other and can't be repeat like one line above it. So they have to be like sandwiched together, literally. It has to be one after another after another after another for your repeats. It can't be like every other one or something like that, because if it is, it's not going to eliminate any of them. Like, well, how do I get rid of all those repeated statements if they're not getting sandwiched together? So use, would you say, sort? Yep, use sort. Correct. Use sort on it, and then you can run unique on it. So if I sort this, check this out. Oh wow, all that stuff gets lined up now, so it sandwiches it together, and then now we can run our unique command on that. Pow. And now all our repeats are gone. Yeah, check it out. Before, after. Yeah, unique gets rid of all the repeats that are literally right next to each other, sandwiched together. Okay, you can't have any spaces in the lines between them, between your repeated entries. So sort's excellent when you need to run a unique command in order to make sure that they all get put together. So that way you eliminate any extra lines, and you can do this with log files too. So typically you don't have to worry about it so much because the log files will do them sandwiched together. Usually when you have the error, they're just perfectly repeated.
If you have an error that comes in the middle of another function, you've got an error that happens and then something happens on the error.
Yeah, if you have the every other line, now that can happen on errors too. You can have it where it alternates, where it's doing it in a loop and it does these series of errors over and over and over again. So maybe there's like 4 different ones, but it logs it repeatedly over and over again, like 1,000 times. Then yeah, sort it and unique it, and bam, suddenly that 10,000 line file might end up being just 10 lines long. That kind of junk happens. You have to be careful about runaway log files. They can really be a problem if they get too big. Some of these log files can actually end up, if you have a program and you made it too sensitive for its logging or something of that nature, you can actually have it eat up the entire hard drive and crash the server. If you don't, that's why you want to partition off your hard drive into different partitions, especially like a folder or something like that for your log files, so that the files or your temporary files or something like that can't get too big and end up eating up your system and crashing your server. It doesn't happen very often, but it can. I've never had it happen, but I've heard it happen to some other guys. But so I know it exists. I know it can happen. It's just one of those things like temporary files. That's another one of those folders where you want to have it blocked off as its own separate partition, because it can get out of hand on some programs or something of that nature with those temporary files and end up eating up the entire system. So that's another one of those. Sucks, but that's the way it is. Any questions on those? Making sense so far? Okay. Awesome. So that is basically, of course you already know who and who is. So there's that. Or, yeah, anyways. I don't remember. I thought you just typed who is. Anyways, well, who just basically gives you information on a user on the system. For instance, I could say like who, Max. I'll probably need to be root to do that. Not Shu, but who. Who Max? Who Max is? Really? No, it doesn't like me at all. Huh?
Is it who space is?
Well, no, you usually do a who like this, and it comes up with the information on them, which is why I'm going like. Well then. Whatever. I don't know what I'm doing. Oh, you know what? They're not logged in on the system. I'm being an idiot. Of course, it's not going to pull it up. If I can check to see if they're on the system with who, if they're currently logged in or not, and it lets me show me what they're running and whatnot. I'm not thinking. Huh? Well, I'm actually a student, so that's one of the things about who. It doesn't actually recognize the fact that I am root privileged. It recognizes that I am actually student. Right. So that's why yeah, I can. Whatever. I that's why I check it with the $home variable space equals slash root. That's why I check it with that, because if I don't, if I check it with who or something like that, yeah, it tells me who is logged in, but it doesn't tell me if they are root privileged or not. I don't run it. So, if they're root privileged, it's not going to come up and tell me that. So, that's why I do that. You can also grep this, of course, from the who command. Pipe it into grep and then search through what they have going on with that user or whatnot. Is there anything in particular? Yeah, that's great, Droid. All right. So let me go over the printf statement because I want to go over that now that we've gotten these others out of the way. And that all those that I just went over are on the Linux Plus. So expect to see them on the certification exam. They love to go over to streaming stuff like this. Like I was going over redirecting this into that, blah, blah, blah. They love that kind of stuff. grepper's going to be on there. Sed's going to be on there. Probably maybe awk type thing is going to be on your Linux Plus. So, those all really matter for the Linux certification. All right. Yeah. So, real quick, let me hit up. Yeah, here it is. All right. So, echo, who is that? Like that, and that would echo out who is that. Now, but a different setup here, if I want to do this with printf, I'd do the same thing, but it's going to be who is that /n, close quotes, enter. Oh, I'm sorry, it's printf. I thought I typed the F and I didn't. There we go. I was like, why isn't it working? Yeah, printf. Does that make sense? Well, okay, we'll get into that in just a second. I can do a lot of stuff inside printf I can't do inside of well, let's look at it right now. Well, actually, no. Let's first talk about it. So the big difference here you see between the printf and the echo, I'm showing you how similar they are because you guys are familiar with echo. So by default, you may notice that it does not go to the next line with printf like it does on echo. Echo automatically does a carriage return every time we run echo. Printf doesn't do that. I had to put in my carriage return. My carriage return, of course, is /n, which is saying new line right here.
If you ran that command without the /n,
it's going to put the prompt on the same line with it. Yeah. See that? Which would be the same as saying what? Echo space -n space. Well, that would be the same thing as putting it on the same line. See that? So that's why we had to keep using our -n option. If we just done printf, we wouldn't have had to have done the -n option with echo. Make sense? So there we are with that. Anybody going, okay, well, they're the same. No, they're not. They really aren't. Printf is like the beefy version of echo. It can let you do all kinds of stuff you couldn't dream about doing inside of echo. Let's have a look at that real quick. Alright, so just some of the stuff you can do. And here's some of the symbols that are used with the percent sign that are inside of printf, inside quotes. And you can have a %s, which would be string, a %c, which would be a character, %d would be a decimal number, %x would be a hexadecimal number, %o would be an octal number, %e would be an exponential floating point number, %f would be a float point fixed number, and %g would be a compact floating point number. And so literally you can have printf statements like this. I need to stop typing print and type printf. Gosh, I'm doing that a lot. That should be printf right there. That would make a big difference. So if I run this, I get two different sets of input and output on this. So let's have a look at this real quick. What happens if I run these scripts? And then we can discuss what happened with printf. Whoa, look at that. We got two totally different setups here, depending on how we ran this. What's going on there? Notice both of those outputs is something you cannot do with echo. Okay, so this is, we basically just went beyond the functionality of echo. All right. This is saying that this is going to be 32 characters wide, S, formatted right alignment on that for the text here. Sure. That's right. You guys can't see this stuff. I forget on this projector. Okay, so let's just talk about the first one. So that's the two lines right there that we just echoed out. So here we are, our %32s there. This means 32 characters wide for the first input, and so our first input is file name coming in from the string here, and that's what's getting passed into this first one, %s. And so we're saying that this is going to be 32 characters long, and it's going to be right justified, basically. And then if I say %s on the next one, that's going to be this file type, because that's what comes next for attributes getting passed into this. That one, we're not specifying a length on it, so it's whatever size it feels like making it, because we don't care. Does that make sense? And so it just places it. So the end result of that, if I could get this thing to actually move, I can't believe I'm actually using the touchpad because it's actually giving me better functionality at the moment. And so that's what we got out of this right here. So, that's what that same thing for that same line there. And you may notice that in the first part here, this is 32 characters long here and right justified. See that? Gotcha. Whereas this one is the one we didn't care about, and so we just said %s. Because we didn't say 32s. We didn't say %32s. The first one there was, justified all the way to the right like that. That's %32s there. Whereas this one right here is just %s for the file type. Does that make sense? And then we did the same thing below, but we changed it just slightly. And that's because we put a negative sign there. Now, if we put a negative here, it makes it left justified instead of right justified. See that? So it's %-32s. I'm sorry. And so that makes it left justified with that %-32s because that moves it the other direction. And then we did a %s again because we didn't care. But of course, with that 32 spaces there, that actually did format it, sticking it over. Yeah, if you want it to be left justified, yeah. And I'll show you that. Here's the proof of it. I just ran it, so yeah. And here it is. No joke. You'll see that the file name here is left justified with 32 spaces in between it. And then file type, of course, is stuck where it was left before because we didn't do anything special with it.
Just stuck file type at the end of the 32.
Correct. It stuck it at the end of the 32 character spacing.
So that's instead of 32, if you listed it as 15 characters,
right.
Would be
correct. It would come over 15 characters instead of 32, yeah. But, you're still counting file name as part of those characters. As part of your 32 characters. I guess it's gonna, Well, it might, but why not just use %s then? That's what I'm saying. If you're gonna do that. So I wouldn't. I don't know. I've never tried to do that, but you can try it right now if you want. Find out through the School of Hard Knocks. Here we go. And that's what we got. We just, got them together. Which should be the same thing as the same %s. So we just do %s instead of 0 there because it just makes it. Yeah, I just use %s. I use 0, but it's basically the equivalent of doing %s. I'll prove that. This is the exact same thing as doing %s. Why? Because it's telling me, I figured it'd do this. It's what most of them do. They don't actually end up deleting your characters. Instead, they're going like, okay, well, we don't have this fitting within the space, so therefore, we're just going to automatically just push it to left and treat it as if we had, it goes to the minimum number of characters by default. So the code's always smart on a lot of these programs like this. It's true, the same thing with a lot of programming languages that have commands like this too. Hold on a second, let me get to the terminal. It didn't go to, I guess I clicked it wrong. So yeah, see, it's identical. So doing, %0s is pointless because it'd be the same thing as just doing %s. Any questions? Okay, now don't forget you can also do like $1, $2, and stuff like that, and actually have it print with inside the printf statement. And so this is really useful, especially when you're talking about fields, right? So you can get it with field inputs, and that's why it's so useful with awk in particular. So printf is used like crazy with awk. And it's also great for loops and things of this nature too. So there's all kinds of stuff you could do with this. As a for instance, real quick here, let's just do this. I should really stop running over my cord. 1 second. That's a great way to make the headset not work anymore. Alright. It's intentional. Okay. So say I come in here and comment a bunch of the stuff out because I don't need all this. Now the one I like the most is the one that's left justified, so I'm just going to keep that one. I don't care about the others here. Alright. And I'm just going to write a real quick loop here to demonstrate this. So for I in star, which should be, everything inside that directory folder, if you remember right from back when we did this stuff. Let me say do here, enter, pop on over. I'm going to do a printf here, and I'm going to do quotes here. I'm going to do percent -32 s space close quotes here space, and then if we do in quotes $I, really need to type I, close those quotes like that. Okay, and then we can do our if statement from there. If, and we can do a -d for a directory. Just throwing together an example here. It's nothing. This is all stuff we've already done earlier. We did directories in here. We did, all this fun stuff here. I like doing a space there. So on and so forth. Of course, I'm putting the then there. We can echo out that it's a directory. Or whatnot. See, and this is an example of mixing the two together. You have basically echo and printf being used together in the same script. Not going to get away from it. Just resign yourself to learning it. It's extremely useful to, and of course we're not doing anything hardcore here, for networking. You only do basic stuff. So you're not going to do anything like, oh my gosh, this is so complicated. No, you're not going to do anything like that. At first it's going to seem that way, but after a while you're going to get it down type thing, and then, it's not going to be that difficult because you just don't go anywhere near as far as a real programmer would go on coding. So your routines are basically just manipulating server information or whatever, and having it auto-generate stuff for you. So that way you're not having to do the work. You're having it do the work instead. So that just saves you a lot of time and headaches. So basically it's a time and headache saver. It's just the way you want it, right? Okay. Yeah, okay, that makes sense, I guess. Alright, so say we got that going on. Got used to doing Python. I was about to hit F5 there a second ago. It's the auto run command is at idle for Python. Been doing lots of Python scripting lately. Alright, pow. There it goes. And so we get the file on one side here, and then we get to echo out what it is. Is it a file? Is it a directory, etc.? And we have it say it accordingly. I made it, okay, so we have file name and file type. I use printf in order to space these out and automatically print all these files like this, and then use the echo statement to put out whether or not it's a file or a directory or unknown or a symbolic link or whatever. -H option made it symbolic link. We didn't go over -H before, but that's what it does. Make sense? Not making sense. Alright. Alright, hold up. Yeah. I'll highlight stuff. I have no problem highlighting. Alright. So basically what happened here, we say for I in star. Star is all the files in the folder, right? And so we're going... I is the individual files we're looping through. So I is going to be whatever file it gets passed to through whichever loop iteration it's going through. It's going through each file loop by loop, iterating through all the files. So we're basically processing each file individually in the loop. So for the first file, because it'd be the first loop iteration, right? You're gonna basically saying, okay, $I here with the %32s, and that's gonna place that file. And it's because I put the dash here in front of it, it made it left justified, right?
And then it's going to left justify and $I variable for the first iteration of the loop, which is the file name.
Right, be the file name for the first iteration. And it'll keep going until it goes through all the files, of course, for the... Yeah, -D would be the directory, right? So if I is a directory, so if the file is a directory that we're grabbing in the loop, then echo out directory. But here, check it out. Remember what the deal with printf is. Printf, you have to put in the /n for it to be a carriage return, because it doesn't automatically do a carriage return like echo does, right? So it's all on the same line, the printf. So it comes down here, and then when it echoes out directory, what does echo have in it automatically? Carriage return. So then it goes to the next line automatically, and that's what's happening. A little complicated to follow that, but that's what's going on. And it also explicitly shows the difference between the two. If we have here a -H, it's a symbolic link, then it does the same thing and it echoes out symbolic link. Of course, that's on the same line. And then going down here with the -F, hey, it's a -F, then it's going to echo out file. Of course, it's going to make a carriage return to the next line. And if it's none of those, then it's just unknown, and then it carriage returns to the next line. And it does that per file. So basically, no matter what, we're going to automatically get a carriage return, because no matter what, we're going to have some kind of echo statement, one of those 4 different possibilities there. Does that make sense? So we're always getting an echo statement, which means we're always getting a carriage line return, and that's what's going on. And that's why we get that output. Does that make sense, everybody? Cool. And so yeah, that's exactly what happened here. And that's the breakdown. Yeah, except for web, which was a directory. It just happened to be that's the case.
And that was booted for whatever directory you were in.
Right, whatever directory the script was in when it ran. Correct. Yep. So, yeah. Correct. It'd go through everything in your home directory if you had the script in your home directory. Correct. Is this making sense? Interesting? Okay. So the printf is more powerful than echo. This is stuff we couldn't do with echo, not even if we wanted to. And this allows for quite a bit of power, and that's really important, especially when we start trying to do stuff with awk, because we're going to need some extra power and capabilities with awk that we just can't get out of echo. So echo is not going to be the preferred method for printing things out with awk. You're going to use printf almost like always. So and it lets you really control this stuff. So let's look at awk now, because that's what we've been building up to. We covered all this stuff just so we could talk about awk. Makes you feel proud, right? All right. So awk basically treats files like they are database records for each line, and each field is basically in the file is basically like a field in a database system for a record. So it literally treats the entire file like a database table. That's how awk works. And you can process the data as if it was a database. You can process the file as if it was a database table, essentially. That is what awk does. And what can you do with it? Lots of stuff. You can embed entire logic structures in it. You can have if statements. You can have for loops in it. You can have regular expressions in it. You can have, if you can just about think about it, you can do it pretty much. You'd have begin and end statements in it for doing a whole block, sets of regular expressions and patterns. So it's very powerful. Awk use regular expressions for and decision structures and control structures. You would want to cat a particular file or something like that, tr it in order to get it into, and then tab it so that it's in the proper format in order to make it compatible. Now, let's look at some other parts to this. So, what's the big deal about awk, and how does this break down, and how does this work? Well, you have your patterns, like so, and they're denoted just like you're used to in your regular expressions with your slashes there, right? Your forward slashes. Remember that from sed? Same thing. And then we have our curly braces, like this, and then this contains actions. Note the spaces. So you don't need spaces around the pattern with the slashes. You do need spaces with your actions. Those curly braces need spaces around them. You can't have it smack up against your actions. And that is a basic format for awk. So how can we use it, for instance? Very simply, let's go back to the terminal real quick. And this would be very simply. Alright, so one of these here, like, oh, I don't care. Right, so say we get this right here, and I really don't want number 2 because that's that stupid X. I just don't want it in my thing. Alright, so say we get that going on there, right? And we pipe that into tr, right? Call on here. We do a /t, like so. Okay, so we get something like that, right? Well, I can then redirect that into awk. This is a very simple example, so you're not going to see squat with this. Yeah, I just piped the stuff coming from the TR. It is. It's over here on the very edge, right there. That's the pipe. It's on the edge of the screen. That's right. And then in here, I'm just going to have my curly braces. Space. Note there are spaces on either side of this. I cannot have it smack up against it. And if I just did a print F, this is really going to be a stupid example, but hey, it is like the simplest awk statement I can just about write. So I guess that's the point of it, really. And expect to see. No arguments. Alright, let's see here. Is it not like? See, this is fun because it printed out this other thing. Alright, let me redirect this into a file real quick with this cut here. I'm going to TR it too while we're at it. Let's just redirect this into a file. Test.txt, like so. Alright, ls. Should see a test.txt. There it is. It took it, good. Alright. Here, I'm too lazy to type all that again. I'm just not going to do it. Frame is going to delete. Like that. And then I should just be able to say, what's it, test.txt. Great. So they changed it. That's what it looks like. Goody goody gumdrops. Well, we could try passing it in as fields, like 1, 2, and 3. For instance, since there's 3 possibilities for fields, so could try doing that. $1, $2, $3, and if I'm not mistaken, yeah. And it processed it, not like I was expecting. Really not like I was expecting at all. Oh, no, I get it, yes. Because there was no, okay, yeah, never mind, it makes sense. Because there was no carriage line return, however, remember it doesn't do, we didn't do a /n in there. Because we didn't do a /n, it ended up putting everything together on one line when we printed it. So it read all the information in as record fields coming in from awk there, and then basically processed it all into a single line because the printf made it do that. If I were to cat out test here, that makes total sense. Hold on a second. Let me just cat this file real quick so I can show you what happened. Of course, it'd be awesome if the what's going on? Why isn't the backspace key working anymore? Huh? Alright, the stupid thing's not updating like it should for the... Or I'm back at the prompt, it's not, just whatever. So if I look at this file here, it took all that data and basically slammed it together. So check it out. You'll see root here, 0, 0. You'll see root here, 0, then Ben, then 1, then Damon, then 2, then 2, then... You see what I'm saying?
So what if you used echo to replace it?
Well, then it would have been doing it per line.
Right.
So, but I told it to print those 3 fields. Now, I didn't have to do it that way. For instance, I mean, I could process however I want, right? Say I didn't want to do those 3 fields, I just want to do the first field. I could do that. That's all the usernames. And I didn't print the other ones. Right, and I do /n, and it'll list them in one line. Yeah. But it's up to you how you want to do it. It'd be even cooler if it was up to me if the stupid thing would show up. Okay. No, it's not stupid. I get what's going on. It's freaking out because it's all on one line. It doesn't like that. And it didn't like what I just did. And I probably need to put it inside of quotes. I'm sorry, I probably need to put that inside of quotes for that /n there. because that should be inside quotes or slash n. It's a special character, right? So strings, so strings inside quotes. So therefore, it must be inside quotes. Make sense? Yeah. So here I took all the users here and I listed them like so. I could do more stuff like this. I could actually put an if condition statement there and make it put several of these per line or something of that nature. Or I can get more creative with this if I wanted to. I could have tabbed them. I could have done whatever I want with it. Now at this point, really, I could just put a space between it and execute it. So now I got them all listed out there with a space in between it. You can do all the same thing here again. What's that? It's not it's just the stupid thing's not refreshing properly is the problem. So it's the issue. It's not a problem with the actual.
So, but with awk, you couldn't.
It's not refreshing properly because I didn't put a new carriage return.
Right, you need a carriage return so at the end of it, so it gives you the
prompt properly. Yeah,
exactly.
you could do that with a condition statement or something like that. So that way, when you get at the end of the condition, that it automatically puts in a new carriage return. You could do it with a condition, like an if statement. You can have an if statement there. You can have a for statement. You can have a while statement. You can do whatever you want, as far as that stuff goes with awk. But realize you are processing this as like a database file. So here I'm doing an intermix of the two fields. What if I change that around some? What if I change that to new carriage return? Yeah. See? Yeah, it sure did. Of course, I could do something about that, right? Well, if I'm going to do a carriage return, if I'm going to slash n. Yeah, it's whatever I want to do.
Well, if you put the
Yeah.
carriage return in the middle,
I could do this instead. Now we're back to what we started with, right? We can do commas. We could do comma space. I mean, it's whatever. Start to see the power of it. I think I could probably get away with the tr command now if I tried it here. On this with this fields, it wanted fields earlier. So it did not like me. Apparently, you could used to do that because that was an example. But the shell has changed some since the old days, and it's an old day example, so it didn't. The newer version apparently doesn't like it. So my apologies. But if I pipe this into a tr here, colon, and then t space, and then pipe that yet again into awk. Alright, and then I don't need the test anymore. Oh man, then I don't need the test txt anymore because I'm piping it in its place. And then now that's on the fly. Make sense? Right. Now I could change this. I could do a cut on this instead now. Could cut this, use a -d for my delimiter, do that right there, and then I could tell it which fields I wanted, right? Maybe I want 1 and 3, for instance. Now we're back to that. Or maybe I want 1 and 6. Making sense? So, very powerful. Lets you really manipulate stuff as you see fit or what you need to do with it. I could print this out however I wanted. I mean, I could literally come in here with this printf statement. Hey, there's no reason I couldn't come in here and say, like, right? I could do this here. I could do that, and then I could come in here and say, something like that. And then what's the next one? A home directory. like that, right? Colon space, there we are, enter. Maybe I decided, well, that's not pretty enough. There's two mashed together. Not a problem. Put that in there. Boom, like that. So on and so forth. Or maybe that's not good because, okay, I really just want the space there. And then, you got, that's the point about this. You got a lot of control over your data. You can really format it however you want by reading in the data however you like and processing it to do what you want with it. And you might go, well, I don't see why this matters. Well, you may need to have things in a certain format for it to work properly with a server or something of that nature. And now you have the control and the power to actually manipulate whatever it is you're trying to work with to make the data appear as it needs to appear in the as a, automatically write a configuration file or something of that nature. And awk lets you process tremendous amounts of data and manipulate it as you would like a database, more or less, because I can actually manipulate it based on the actual fields. It could be useful for a report. Yeah, you can pull. Right. Right. You could do like report on the users. You could have it do other things besides that. You could have it take in the users and have it write out like an LDAP hierarchy information set up, and check to see if it already exists for an entry. If not, insert the entry into the file, and thus now it's part of the actual directory tree. And all you did is run the script, and bam, it does it. So yeah, so it's kind of powerful. And so you can use this for automation of data for your network without having to do really complicated programming. It lets you stay fairly simple. And so it really comes down to mangling text and strings. And that's really a very important aspect inside of networking, is being able to manipulate text and strings. That's why they'll use Perl on a regular basis, or Python, or Perl and Python together with shell script. I just finished writing a tool for manipulating video where I use Perl, Python, and shell script all together. And I called the shell script and the Perl from Python inside of there as shell commands. So using the commands function, I imported it with the import space commands. I imported that, and then I was able to actually call shell commands directly inside of Python. And then also I piped that to a Perl script when I ran the Perl on there and manipulated it for doing string mangling manipulation, and then I outputted that result back, and I manipulated it several times. So the line was like, I don't know, super long. It was ridiculously long. Just taking out more and more information I didn't need. I was able to extract information on the videos by doing that. So I got statistics on the videos that I needed in order to process and transcode the video, for instance. And that was commercial work I did, outside of here, of course, for a client. Huh? Yeah, and also I get 20% of the company too. So, yeah. So yeah, my payday really goes when it goes up in sales. But yeah, I do get some money from time to time while I work on it. It's kind of difficult right now with the economy so bad because a lot of clients just run out of money. Honestly, on contract jobs right now, it's really frustrating. But you're sitting there working on a job, they love what you're doing, and then they run out of money. They just can't literally pay for the work you're doing at times. It's frustrating. That happens. Let's see here. Let's look at some more complicated ones besides this. Of course, you can also use regular expressions in there. Don't forget about that. As far as that goes. Remember our regular expressions from good old said? They would go like that right here inside these slashes. Remember all that stuff? Let's have a refresher real quick. So literally, you could even run it through sed before you drop it into awk if you wanted to too, or grep. You could grep it before you awk it. I mean, these lines can get really long, as far as that goes. As you pass this data around to do more and more with it. So remember this whole thing where we were doing editing with substitution strings? We used the -e option. Well, we got the same kind of thing going here. Here's our regular expression commands, and these same regular expressions also work with, sed. I mean, with awk and also grep. So we can manipulate this how we see fit. I think. Well, let's have a look at this. For instance, maybe I'm only interested in the characters that are actual char characters. So I mean, we could do something of that nature. Find character sequences. All right, so sorry. If we come back to our prompt, and what would be a good example before we run this again? Let me just whatever. I don't care right now. Of course, it's going to error out. I expect that, but because I didn't put anything in that regular expression, so yeah, it's throwing a fit at me. Oh, and also put inside those curly braces, which I shouldn't have done too. But if I just look at this file before start manipulating it, see if there's anything of particular interest, and of course there is. We could manipulate it based on digits or numbers and things of that nature, or we could look at strings of text as far as that goes. So what we can do here is I can set up regular expressions on this, like so, and what we could do is something like, oh, I don't know, maybe I'm only interested in mark. Because I used regular expression patterning matching with my awk to only select mark. Maybe I want something a little different. Maybe I want to be the beginning of the character of the line, right? It's carrot top. I want M. I'm going to match that with a star. Not really. Not sure where I went wrong on that one. It's really not what I was wanting. Yeah, exactly. Mark and max, and I didn't think something through. That's for sure. I defined M, so I figured that would stop the others from getting listed. Max. Okay. Shouldn't be doing that. Or at least I don't think it should. I'm not thinking through something properly, that's for sure. Yeah, that's the thing. That's the thing. Once these lines start getting long like this, you get to start remembering how it gets manipulated before it gets to here. And I'm obviously not thinking about something correctly here. I'm not sure what that is I'm not thinking about right now. So unfortunately, my demonstration here is not the greatest. But the point here is you can actually use these regular expression pattern matching here that you learned from SED in there with this too. Any single character match, yeah, it's a dot there would be fine. I could try several dots. Let me try dots. I just want to see if it works. Not feeling particularly excited about being. Well, you would think. Of course, that would do it without me doing squat. I said beginning of the line and then I said M, so everything's starting with M.
You had a star, so the star told it.
Everything. But I should be able to sit here and say like 4 of them. It's just gonna give me, including stuff that isn't 4 of them. So I'm got wild character, single characters.
So that would have given you male mark.
Yeah, I would have thought, or at least I would have thought. Yeah, apparently not. But just putting the M there did say beginning of line, and it did do the M, so it did do male, null, MySQL mark, blah blah blah. What we could check here real quick is do the cat again on this thing, and maybe I'm only interested in stuff that ends with a K. I don't know. Alright, so maybe instead of doing this right here, the start thing here, I do a K and do a $sign here. It should give me all the ones that end with K for it, which was /mark. So there's an example of using regular expressions with awk for manipulating this data and everything. Yeah. Here's the command again that did that. And of course I cut it and I was grabbing the first field and the 6th field. So we're only really looking at this file here. You have to keep in mind what we're doing here. So remember we're only doing that cut statement. We're only doing that field there and this field here. So cut statement limited just down to those 2. And after that, and it did it right, check it out, none of them have a K. Just realize this is the end of the line here. This right here is the end of the line. So K is at the very end of that line for Mark, but it's not for Max, it's not for Server, Spidey, Joshua, etc. All the way down the line, nobody else has a K at the end. So that's what happened there. And then here I took the colons with the tr command and turned it over into tabs so it's compatible with awk. And then when I looked into awk, I said, okay, I only want the ones that match a K at the end of the line. And it says, all right. And then we went to print here and we said, all right, for the username for the first field, we're going to print out username space and then the first field here, which is going to be what? Mark. Right? And then it comes over here and we say, all right, cool. And after that, we're going to do a comma and a space, and then we're going to tab it. We're going to say home space directory colon space, and then we're going to do $2, which is the next field. Now remember, since we cut it, we only have 2 fields, and the 6th field is actually the 2nd field for awk. So in this case, it's going to be /home/mark, and that's what gets displayed. So when I ran this, check it out. That's exactly what happened. We got username space colon, user space name colon space mark comma tab home space directory colon space /home/mark. Make sense? And all that matches up with what I just said. And this is a simpler awk statement, believe it or not. Let's look at a more complicated one. Because awk can get truly interesting when you look at what you can do with it. It can get kind of crazy. You can do decision structures with it, where you decide something is greater than or less than something. For instance, let's see if I can't give you a practical example of this. And this is cool that we can do this. All right. So we got pattern matching and all that, but we can also do expressions of particular All right, hold on. Let me show you this. All right, so note here that in our original one, that number 3 is a user ID, right? Can anyone tell me the significance of a particular number set for user IDs? Yeah, you want to be away from the rest of your processor. So what number do I need to have for my users that separates them from the rest of the processes on the system? 500 and up. Yeah, 499 and below is system reserved. So what I can do here is get rid of my search parameters, if you will, and I can actually say which field it is I want to manipulate, which will now be the second field since I changed that over here from my cut here. I changed that to 3, so I'm now looking at what? The user ID, which would be coming as the second field into awk, right? And then I can do a test condition on this. And we're going to say that if that condition is greater than 499, right, then we can display it. So it only shows me the users that are above 499. That would be valid users on the system and nothing below it. Pretty cool. Very useful. Say I need to actually propagate this into my LDAP or something like that. Now I'm only grabbing the users out of this file that actually match the user ID number. That is what I want, and then I can actually have it generate that file for me with the proper data. Making more sense? This again is very simple. I haven't gotten to the complex stuff, but you start to see some of the implications of it. Let's see here if I can. I just want to throw up like one complicated example just to show you. You can also add and subtract, multiply, divide inside of awk. You can, I'm not kidding you, you can do mathematics inside of it. You can actually run loops inside of it with your mathematics. You can also do and or statements with your decision structure. So you can, I did this right here, but I could have gone, okay, so it's 499 and but less than 1,000 maybe. So I could do that. Like I could literally come in here and say, but then $2 is less than 1,000, for instance. And I only get ones in between 500 and 1,000. So you can do more complex decision structures as far as that goes. And to make things even more interesting, besides that, let's look at some other stuff we can do here real quick. You can count your lines. You can do some mathematics. Here we go. Yeah, it's begin end set up for actions. All right, so here's the more complicated awk configuration. I'm going to type this up real fast. This is where you get into the really complicated stuff with awk, because we've just been brushing the surface with it, basically. I'm not going to go into this really long, in-depth thing in awk. It'd be like 4 or 5 hours long. I'm not doing that. Sorry, I'm not. I know everyone's depressed about that. I joke. I kid. I know you're not. So, but besides in here, don't forget that I could also have inside of this. I can have my decision structures in here. So, like for instance, I could have my greater than, less than equal to, greater than equal to type stuff here, equal, and then my actions. So we just saw equivalency. You might be able to say single equal. I think it might be single equal for shell, starting to think about it. Equal is what's used in a lot of other programming languages, so I'm probably mixing it up. Yeah, and then you can also do the and the or. Yeah, double pipe is or for decision structures. Same thing as -O or -A. You could do -A or -O. It's equivalency. If single bar like that is a bitwise OR operation, and realize that that's no longer piping when it's inside of a decision structure. Like that has a totally different meaning. So, if I come in here real quick on this one here, double pipes means or, this or that type thing. But if we look at awk for its decision structure, and if I want, I'll just say awk here like this, and then it's gonna be inside quotes. Of course, all this stuff's inside quotes like that.
Is there these three shells that you have sitting there that have some really cool stuff about set, printf, and off? Can you upload those to the?
Already have. You got the video. You already have said video.
No, I know the video's there. I'm talking about just those scripts.
Oh. Yeah, I could throw it up there.
I know it's in there, but in order for me to have it separate from the video, I have to just have it up on the screen and copy it.
Okay.
I just wondered if you could put those.
Yeah, I can pop it up there. I don't care. I think I can just upload it as an individual file.
Yeah, it is.
Yeah, that's cool. Don't worry about it. I will do that. So this is the more complicated one. You'll see what I'm talking about in just a second. Yeah, that's the start of the giveaway, right? And this is where we get. It's going to actually be more than 2 lines. This is where we get into this begin, and then you'd have something like actions in here, and you just start to see where this is going, Here, and then I can say slash patterns like this, and then space my actions, and then I can do yet another set of that, which I'm too lazy to type that again, so I'm not going to. Oh, well, copy and paste works out great. Alright, so then I come down there, and then I could do something like an end here, and then again, space, and then curly brace, and then actions, like that, and then I can end my quotes down there. And that is a more complicated, and then space, and then whatever file it is, or files. Yep. So, that's more complicated. So let's look at a real world example of that. What's that? Right, I didn't put in the patterns or actions and realize that stuff can be piped into this in place of file there. So, yeah, basically, this line is going to go on for quite a long time, essentially, yeah. So you end up getting stuff like, oh gosh, let's just give an example here real quick. I'm going to do it in here. Alright, so for instance, it'd be like awk. And on mine, note, I'm not even piping anything into this, and this is how long it's going to be. Begin. Literally, you type begin. And then open curly brace. So again, just starting off here, we gotten easier already. Printf here, and then in quotes here, we do a %s here, and then a /t for tabbing it. So we're going to display something, we're going to tab it. Alright, and then we're going to say comma here, and then we're going to say file name. Like this. Space semicolon, and then close curly brace for the first piece of this wonderful puzzle. And then we're going to come in here like so, and we're going to say slash. And so we're starting our regular expression here, right? And then we're going to do our carrot top again. And we're going to say space, and we're going to say star, and we're going to say $sign to end. So basically all the characters, and then star at the not star, but $sign to end the line. So basically only lines starting with a space in them, because it has to start with a space because we put that space there, right? Alright. And then we space after doing our slash to close our pattern matching setup here. And then I'm going to do this for our actions. And then you say like x, sorry, is plus equals 1, because remember, you can't have spaces in shell. We are doing assignment like that. Alright, and then we have that right there. And then say we come over here and we end this from there, as far as that goes. Yeah, I'll keep that tabbed. I don't feel like fighting it. I don't have to. I could space it over and make it look all pretty, which is probably actually a good idea, but I didn't. I'm going to. I can't stand it. Alright. So, here we go. And here I'm just giving an example. I'm not going to actually execute this. I'm just trying to show you what could be done with it. Times. So 100 times, and then in this case, x slash nr, things like this, close parentheses, space, semicolon, space, print, f, space, quote here, and then space, and then percent s, like so, and then slash t, and then percent 3 dot 1 f slash n, close quotes, comma x, comma ave, semicolon, space, close curly brace. Sorry, I didn't mean to have that extra curly brace in there. And then close that down, close quotes, space, and then whatever the file name was going to be. And in this case, they were passing in like that for loop we were doing earlier. And in this case, they were doing I, so they're looping through each file this way and having it manipulate the file on the fly with a for loop where we're looping through different files and things of that nature. So basically, this could be part of a for, I in something like that. It could be a star here. In this case, they did a $ at symbol type thing instead. So for, and then a do, and of course this would all get tabbed over. But you get the idea here with this. If, and then you did brackets here, quotes, $I, close quotes. So it's bracket. So semicolon then. It's just a little bit more complicated. Just a little bit. Else here. And then here in this case they're echoing this out. And they're saying error, file not found here. So error. $I here, not a file. Close quotes, and then we're redirecting this with an ampersand to the error messaging logging to be computed, and of course you would then end this with a fi backwards like that, and then we end that with a done. Oh, I'm sorry. Yeah, no, so this is just an example of what can be done with awk. And of course, that's without any redirection to it. That's without doing tr or cut or anything like that. If we did that, it'd be more complicated than this. So, this is like a more advanced example of what you could do with if statements. Or you can have if statements inside of awk too, not outside. Like this one's outside of it, but you can actually have the if condition statement inside of awk if you like. And in this case, we have it going through a loop here. I've seen more complicated ones than this, by far, like way more complicated than this one. But this is a good example. That one's really long. I don't know if I want to type that. Essentially, what I just typed, like, so okay, you see how we have these for loop and this if statement outside of awk? you can put that inside of awk instead. I kid you not. So, meaning that you would have this inside the curly braces here. Essentially, you could do something like, oh gosh, I really don't want to type all this. So basically, you could do something like this: awk. I just want to show you one last example because this thing does get kind of crazy. Of course, now you know what the %s does and all that good stuff. Comma. And remember what $0 does. $0 is when you have no attributes coming in. Semicolon. So it's just the actual command that was typed at the prompt, essentially. All right. And then from there, they get crazy with it. From there, they go if here and bracket, open close, opening parentheses here, if $2 here, tilde slash $, open bracket 1 through 9, close bracket, open bracket 0 through 9, close bracket, star slash dot, open bracket 0 through 9. I think this one example will just encompass both the if and the for loop, so you see how to go about doing it. I'm not going to require you guys to do this, don't worry, but I do want to show you an example of it. Alright, so we do that right there, tab that again, print f, like that, that's a star, semicolon, bam, next line here, then another if. Encompassing that, we have $3 here, equal to, and this is an actual real working example. I'm not even sure what it does, as I haven't really looked at it, but I do know it works. Print f, order. Alright. Oh, I hate that structure, but alright. Just think that's ugly when people code like that, but alright. Print f, like so, and then we're going to say slash n, close quotes, semicolon, like so. Close curly brace. Go back to this one, and we're going to say close that one, else that one, open that one, enter. If I didn't throw a for loop in there. Oh well, good enough. I'll take this one. This is difficult as I really want to get. Greater than 75. Press. Tab it over again. Print f. Alright, else. Almost done, guys. Print f. Alright. Close it, close it. In this case, the name of their file was fruit underscore prices dot txt semicolon. All right, and that is the awk statement. And I'll highlight that for you. I'm going to say that real quick before I forget it. That is one awk statement with nothing being even passed to it. No file redirection or no streaming, character streaming. What's that? Yeah, I don't have that, but that's what they're processing is that file. Yeah. So instead of doing like all that file redirection stuff I was doing with the cut and the TR and all that, they actually already have a file already preset and ready to go. If they had that, you can imagine adding all that on top of this. Right, exactly. So they're doing checks for ranges and things of this nature, and are able to do different conditions on different fields. So on the third field, they're checking for a particular number, and I'm not sure what that number is. It might be a price or something like that, or it may not be. The second one here, and again, I really wish I knew what this. Okay, I kind of do know what this file does. Okay, so the third field on this is the quantity. So if it's 75, if it's less than or equal to 75 units, or case pieces of fruit, then it's a reorder deal here. Whereas on the second field here is the price per pound. Is what the second field is. So they're literally processing it. So that's what they're doing here. They're saying the second field here, we're going to process this, and so this is you're starting out with your, if you can see my cursor here, that's starting your regular expression, and then we're escaping out the dollar sign because it is an actual dollar sign for the price, right? And then we're saying 1 to 9 because we're only looking at prices that are at least $1 or higher type thing. And then they're saying 0 to 9 after that, and then star after that, and then we're escaping the period key. I mean the period. So for a dot, for numeric value here. So I guess really that's anywhere from $10 and up type thing from there, really, because you consider this is 1 to 9 for the first digit, and the second digit is 0 to 9. So it's got to be at least what, $10 or up.
10.00 to 99.
Right. Yeah, to 99 cents. Yeah, either 0 or up to 99 cents. You're from 0 cents to 99 cents by doing these brackets here for regular expressions, and then at that point we end our search pattern for our regular expression by putting that other slash there. So that's essentially how they're doing it, and they're doing it with a series of if statements. You can have else. Now note you could have also had a loop here, and you could have looped through multiple files and processed multiple files all into one output file. No kidding. Is this making sense? Correct. For all your different files and actually output it. Correct. Right. Does that make sense?
About as much as it can right now.
So essentially that's what's going on, and of course once they hit these different quantities here, they're printing out the statement reorder. If not, then they're just going to print out the characters return and go to the next line, and they're going on and doing the same thing over here. They're doing reorder here for this one. So if it's
Reorder, is that a bracket or should that be a slash?
where which
Second on
Reorder bracket in.
yeah.
oh, I'm sorry, you're right, that is a slash in. Thank you, I did make a typo. No, you're right, you're absolutely right, that is a typo. Very good. Yeah, no, he's understanding it. So here we're saying else. So if it's not $10 or whatnot, or up, we're looking at this other one here. Now I would imagine you would have quite a bit of money racked up with that size order. But say it's less than that, or something like that. I guess I would figure it'd be less than that. since they covered such a big range here, then you're going to be hitting these other if condition statements down here, and then you have the spaces in there if you reorder, and it's coming down and saying new line there. So it does display it differently accordingly. Make sense? Okay. Again, we're just saying less than 75 here for quantity for $3 down here, and then else if not, new line. So nothing real complicated as far as what it's actually doing. It's really kind of boring, but it is a good example of just kind of how crazy you can get. You can get crazier in this. Again, this could all be inside of a loop inside of awk, and we could have file redirection happening from several different commands going into awk. So this can be a real beast by the time it's all said and done. Yeah. I'm sure it was ridiculous. Yeah, awk can get kind of complex as you can start to get the idea. This is the most powerful command in shell, and you can see why it is. And that's what awk does. And they have examples here of a while statement inside of it. But yeah, you can just throw a while in there like you would expect to do, and it'll loop through through all this. So yeah. Any questions? More than you can even think of, right? That last example right there is just one big question, right? So, but that right there is just two different examples of it, and that's basically awk there. And I didn't want to get too crazy with it, but yeah, that's how awk works. And yeah, there's a lot of stuff that goes into it and what you can do with it and manipulate with it and how powerful it is. And that's what that is. All right. Awkward teen years. I don't know. I really don't know what it stands for actually. But it is extremely powerful. It's basically like its own little programming language of its own. It's like a whole other process, if you will. It's very powerful though. Of course, in my opinion, like if you start getting real crazy with that, that's where you really do want to check out using something like Python or Perl. That would be my preference to handling some of this stuff. Because you can really actually manipulate this stuff a lot easier typically. But sometimes, I'm not kidding you, it's easier to do it in shell, and then you embed that shell inside your Python or something of that nature, using OS commands or something of that nature. So, it depends on what you're doing as to what you want to go about doing, because it can really make a big difference here for how complicated things get. So you basically just take the path of least resistance, and wherever that is, that's what you want to do.